Okay, I am going to take the Coulombs law quiz, and we'll see how easy or how hard it is. And when I took it, the first question I got said, Coulomb's law is used to describe which of these forces? Well, we are in the electricity unit, so it makes sense that electric would be the force we're talking about here. Let's see what number 2 is. If you cut the distance between two electrically charged objects in half. Okay, so basically what we're doing here is we're starting off with the equation, and what we're going to do first is we're going to put in ones for everything, even the constant. And if we go 1 times 1 times 1 over 1 squared, we get 1. But now the important part is we're going to make a change. We're going to compare that 1 to something else. And it says we're going to cut the distance in half. So this 1 squared is now going to be half squared, or 0.5 squared. So if we go 1 times 1 times 1, we still get 1 on top. But 0.5 squared is actually 0.25. 1 divided by 0.25 is 4. So 1 compared to 4. Well, that means if our 1 became our 4, that is quadrupled. So there's number 2. Number 3. Let's see here. You have two electric charges, 4 times 10 to the negative 6 meters apart. One of the charges is this many coulombs, one is that many coulombs. How many newtons? Okay, so here what we need is a calculator. Don't even know if we need to write anything down. So K is 9 times 10 to the 9th, so we'll have 9 times 10 to the 9th times, and then our two charged objects. One of them is 2 times 10 to the negative 7th, and then times the other one is 7 times 10 to the negative 9th. And then divided by, and then what do we have here? The distance is 4 times 10 to the negative 6. So 4 times 10 to the negative 6, but don't forget that gets squared, and then we just hit equals. So I get 787,500. So 787,500. Let's see what's next. If you double the charges on both of them. Okay, so that's back to this thing again. Let me clean this up really quickly. So we already know that if we do 1 times 1 times 1 over, same color here, 1 squared, we got 1. But what if instead it says we're doubling the charges on both of them? So these are the charges, the Q's. So if these both became 2's, 1 times 2 times 2 is 4. And it doesn't say change the distance, so we'll leave that a 1. So 4 over 1, so 1 versus 4 over 1, that is again quadruple. Okay, so next, Coulomb's law is described by an equation that solves for a number of, well, it finds the force, and force is newtons. And then the last one should be another calculator one. And here it is again, so let's clear this out. So K is always 9 times 10 to the 9th times, one of our charges is 8.6 times 10 to the negative 8th, so exp negative 8th, times, the other one is 7.9 times 10 to the negative 9th, so 7.9 exp negative 9, and then that all gets divided by, and here's the distance squared, so that's 1.8 times 10 to the negative 6 squared equals, and well, 0.222, so we only need 2 of these decimals, so 1887222.22. So let's see here, it's 1887222.22. And let's finish the attempt and see what happens. And we wind up getting all of them right. So that quiz is basically a combination of understanding basically how equations work and how to use a calculator with scientific notation. That's it. So under 5 minutes, there is the Coulomb's law equation quiz.